The purpose of this video is looking at volume in building contexts. The outcomes, you need to understand that volume can be calculated when the height or the depth is very, very small. And we also need to calculate volume of complex shapes. Let's look at example 5 on page 176. We're now going to calculate the volume of mortar needed, and what that means is the wall is going to be plastered. So a very thin layer of mortar is put on the outside of the wall, and we are actually calculating the volume of the mortar. Now remember, volume is the area of the face, so in other words, the area that we calculated in the previous example, minus the windows, times the depth, which is going to be the thickness of the mortar for the wall. The area of the face we calculated in the previous example was 37,46 meters squared, and the mortar here is 10 millimeters thick, which is very thin. Now, if we look at this example, we've got meters squared and millimeters. So the first thing we have to do is go and find King Henry. King Henry died miserable death called measles, and I'm going to convert that from millimeters to meters so that I'm working in the same units. When I go that way, I divide. How many bunny hops? 1, 2, 3. 1, 2, 3. I put a 1 in front, so I'm going to divide by 1,000, and 10 divided by 1,000 will give you 0,010, and that would be meters. So this is going to be 37,46 meters squared multiplied by 0,010 meters. And if I multiply those two together, I'm going to get 0,375 meters cubed. The volume of plaster needed to plaster that wall, excluding the windows, is 0,375 meters cubed. Look at the next example, and that is to be able to build a pillar from cement and determine whether we'd have enough cement. Example 6 shows this pillar needs to be created from cement or concrete, and it's also a complex figure. So just like the area of the house was a complex figure, we're going to break this into the top and the bottom, which are exactly the same, and then the center piece is a cylinder. So let's have a look at that. We have a rectangular prism at the top and a rectangular prism at the bottom. So we know we're going to multiply this by 2 because there are 2 of them. The area of the face is 45 centimeters by 45 centimeters. So the area of this will be, if I multiply 45 by 45, I will get 2,025 centimeters squared. I'm going to multiply that by the depth or the distance traveled to get the volume, 10 centimeters. It's important that you check your units are the same, which they are, and this would equal 20,250 centimeters cubed. It is 3-dimensional, and therefore we have centimeters cubed. But remember, I have 2 of these rectangular prisms. So if I multiply that by 2, I'm going to get 40,500 centimeters cubed. That is for the 2 rectangular prisms that make up the top and the bottom. In between, we have a cylinder. Now remember what I said. As soon as we have a circle, the first thing we do is we write down the diameter and we write down the radius. Well, from this, we can see that the diameter is 35 centimeters. If the diameter is 35 centimeters, then the radius is 17,5 centimeters. So I find the area of the circle, the area of the face, times the distance traveled. Pi r squared is your formula. From this, we get the radius is 17,5. So I'm going to find the area of the face, which is going to be 962,1127 and so on centimeters squared. Then I'm going to multiply it by the height or the distance traveled, which was 130 centimeters. Make sure that your units are the same, which they are. And if I multiply those together, I get 125,074,6575, and these are centimeters cubed. It is three-dimensional. Now, to get the total volume, I'm going to add this amount to that amount. Check that your units are the same, which they are. So if I add those two together, 40,500 centimeters cubed plus 125,074,6575. If I add those together, I'm going to get 165,574,6575 centimeters cubed. I should have put my centimeters cubed there. So that is the total volume of that pillar. But remember, I've got to see if 150 liters would make that. So I have got centimeters cubed, and the only conversion I have is 1 centimeter cubed equals 1 milliliter. So if I've got 165,574 centimeters cubed, then I also have 165,574,6575 milliliters. But remember, we have to get to liters, so we go and find King Henry again. King Henry died miserable death called measles. Now remember, these are liters, milliliters. So I'm changing from milliliters to liters. If I go that way, I divide. How many bunny hops? 1, 2, 3. 1, 2, 3. So I divide by 1,000. And if I divide by 1,000, I'm going to get 165,574 and so on. These are now liters. I don't even have to round off because I can see that 165 is greater than 150. So therefore, I do not have enough concrete.